Hello students, let us try to understand the concept of hybridization student. Okay. So when you're talking about the hybridization student, this is hybridization is intermixing of orbital. Okay, this is the intermixing of orbital. Up intermixing of orbitals means what type of orbitals? No, that is have different shape. If you are having the different shape of orbital, okay, shape of orbital, okay, orbitals should have different shape orbitals of same atom of the atoms, okay. So and second point is there, no, different energy orbital. This should be there, different energy orbital, okay, different energy orbital, okay, of the same cell, of the same cell. So if this will be same cell, so what will be there, student? These two will be intermixed together. They are going the intermix, okay, and form equal number of, no, form equal number in the same, that is same number. You can see, student, you can write the better word is form same number, form same number of new orbitals having, what is the property, student? Having same shape. Should be same shape and same energy. Then this process is known same energy is known as hybridization, is known as, hybridization. So hybridization, when you are talking about, student, what is this one? Different shape of orbitals of the same atom, okay, and different energy of orbital of the same cell. They are intermixing together to form a same number of new orbitals having same shape and energy is known as hybridization, okay. Now, student, when you are talking about this, what the things is there, we can study, that is types of hybridization, okay. This is types of hybridization. So there are so many types of hybridization are there, student. In which the very first one is sp hybridization, then sp2, then sp3, then sp3d, sp3d2, and sp3d3. So total number of type of hybridization is 6 type. 1, 2, this is 3, 4, 5, and 6. These 6 types of hybridization is there. Now the very first one is sp hybridization. So sp hybridization, if you talk about, student, so what hybridization it will be we going to, that is sp means what? That is one s orbital plus one p orbital, okay. These two undergoing hybridization, so this will form, that is two new orbital, okay, two new orbital, okay, new orbital. These two new orbital having same shape and same energy, same shape and energy, same shape and same energy. And after forming this same shape and same energy, what they will do, student, what they will do, that is the two orbital should have the maximum bond angle. So this will form, that is sp hybrid orbitals are like this, okay. And bond angle is how much, student? That is 180 degree, okay. For example, suppose if you talk about BeCl2, student. So B, you see how many? 4. So this is 1s2, 2s2, and if you know 2p 0. So p orbital is vacant. Here is 2, but it required the, 2 unpaired electron to form 2 bond. So this was the ground state. Now beryllium, if you are 4, you are sending excited state, student. So if you are sending excited state means this one electron will jump here. So configuration is there 1s2, okay, 2s1 and 2p1. Now you can check out, student, there is the one unpaired electron. This one unpaired electron, two unpaired electron it become. Earlier there is no unpaired electron, now two. And this is only s orbital. Here is one electron is there, and this is the p orbital. Here is also one electron. Different shape is there, different energy is there. They are going to intermix, okay. So how you are getting sp hybridization, okay. So sp hybridization, after sp hybridization, they will form the linear shape two orbitals with which that is chlorine atom is getting attached. So here chlorine atom is having p orbital, this is getting attached, so it is the, this is the beryllium, this is chlorine, this side again chlorine. Okay, this is again chlorine. So this is what is, you can say that is bond angle is 180 degree, or you can write, or that is beryllium is there, here is Cl, here is Cl. So this is the structure of BeCl2 and bond angle is 180 degree. Now next one, next hybridization is sp3 student. sp3, whenever you are talking student, sp2, not sp3. So sp, when you are talking about the sp2 student, so you by the C you can orbital, you can see that is 1s orbital plus 2p orbital. Okay, so 1s orbital and 2p orbital, they are intermixed together. Okay, so what they are giving student, they are giving sp2 hybridization. Okay, अब sp2 hybridization, if we talk about student, s orbital is like this, and then 2p orbital, then this is 1, and what is the another is there, this is also 1. So these two are there, so this, this is the sp2 hybridization. So sp2 hybridization, whenever you talk student, sp2 hybridization, so three orbitals are getting involved, 1 2 3. So they will form three new orbitals. So how will be the three new orbitals? This is 1, this is 1, maximum distance they will be there student. So three new orbital, bond angle will be that is 120 degree. Okay, up now student, this hybrid orbital we have to explain with the help of example. Okay, so example you can take student BCl3. So if you take BCl3, the central atom is boron. So boron is having 5 atomic number, this is 1s2, 2s2 and 2p1. So this is the inner shell, low energy, but this is the valence shell only we get involved in the hybridization. In this case student, this is ground state configuration, and here only one unpaired electron is there. But it required actually how many unpaired electron student? You can see it required the 3 electron, because 3 chlorine atoms are there student. So for 3 electron, what we have to do student? Okay, for 3 electron, what we have to do, we have to send it into excited state. So boron 5, it is going to excited state. So if it is going to excited state, so one electron will jump to here. So this is the configuration, 1b 1s2, then 2s1 and 2p2. So here we can make the configuration like that. So here is 1 2. Now 3, for 3 bond we are having now the 3 unpaired electron, right student? So 3 unpaired electron now we are having, and with these 3 electron, what we can be able to do student, what we can do, that is 1s and 2p, sp2, it will go sp2 hybridization. Okay, this is going sp2 hybridization. So sp2 hybridization means that is 3 new orbital will form, because this is 1 2 and 3 are getting involved. So 3 new orbital is forming, and we are having the other atom is there, we are having the chlorine. So we are, chlorine is having the p orbital student, so they will be forming like that chlorine. So here will be the double bond. If you talk about this as chlorine, here is also double bond, here is the also chlorine, so here is also double bond. So this is a double bond means single bond, this is dash line actually I want to say. So if you see here student, this is the chlorine, this is chlorine, this is chlorine, and this is the bond, here is boron. So here is bond angle is how much, 120 degree. And shape, if you join together student, this shape, okay, so what is the shape is forming student? Trigonal planar, trigonal planar. One more example I am explaining student, if you are taking BH3, so BH3 also example of the this type of hybridization. How? So boron, if you talk about a student, this is 5 electron, this is 1s2, 2s2 and 2p1. If you do the configuration, here is 1 2 and here is that is 1. Okay, this is the ground state configuration, boron 5, this is the excited, okay, if you are sending excited, so this one electron from the 2s2 it will jump to the 2p2. So this is coming, that is 1s2 inner shell. So 2s1 and 2p2. So 2s1 this is 1 electron, and 2p2 if you talk about, that is 2 electron. So total if you talk about, so three new orbitals are forming. So three new orbitals are like that. You know how the three new orbital will form, student, you can make it out. So this is the, top, here is the, so three is there, okay. The shape is trigonal planar, and hydrogen is having the, hydrogen is 1s1, so that is s orbital. So this is hydrogen is getting overlapping like this, okay, overlapping. So this is hydrogen, this is hydrogen, this is hydrogen, this is boron, okay. So student, there is will be the dash line here like that, this is also dash line here like that, and this is also dash line like that. So now you see trigonal planar, and bond angle if you talk about how much will be there, student, 120 degree. So this structure is known as what? Trigonal planar structure, okay. This is the two hybridization we explain, student. Now we will study the, so next hybridization type is sp3, that you try to understand, student. sp3, so sp3 hybridization means 1s and 3p orbital. So 1s means what is this one? Spherical shape, plus this we are asking, that is px, plus this is we are talking, that is py, and finally we are talking about, that is pz, okay. So these three orbitals are going to intermix together, okay, and they are intermixing together, they are forming, that is undergoing sp3 hybridization. sp3 hybridization means 1 2 3 4, four orbitals are joining, so four new orbital will form, student. So what, how the, this is the 1, this is 2, this is also 3, and this is the 4. So this shape if you join together, all together, student, so this will give, that is tetrahedral shape, tetrahedral shape. This is the tetrahedral shape, and bond angle is 109 degree 28 minute, right? Now student, we are going to understand with the help of that example. I am taking the example CH4. So if you are taking the example CH4, student, carbon required 4 bond. So carbon 6 is there configuration, this is 1s2, 2s2, 2p2. So in this case, if you can see, that is only 2 unpaired electron is there, but how many unpaired electron required, that is 4 unpaired electron. So this is the ground state. Carbon we are 6, we are sending, that is excited state. So if you are sending excited state, this is the 1s2, 2s1 and 2p3. So here will be, that is 1, and this will be, that is, here is 3 are there, right? Now this all is going to undergoing hybridization. What hybridization? sp3. So it is going sp3, so this is forming like this hybridization, student. And that is, if it is going have sp3 have 4 new orbital will form, 109 degree 28 minute, and then what will be, hydrogen is there, so 4 hydrogen will be forming like this, okay. So here is the 4 hydrogen atom, okay, here is the 4 hydrogen atom, okay. And now if you see this overlapping together here like that, okay. So this is the overlapping, so this is the tetrahedral shape, tetrahedral shape, okay. This is the tetrahedral shape of sp3 hybridized sp3 hybrid orbital, okay, student. So this is what we understand the sp3 hybrid. Now student, sp3 hybridization if you talk about, so there are so many things you can understand. Other example are there. If you talk about, this is the nh3 is there, you can explain. Water is there, there also you can explain the sp3 hybridization, okay. So ethane is there, student, C2H6. So this all you can explain the sp3 hybridization, okay. Now let us understand one more hybridization, student, and that we are talking about sp3d hybridization. No, next one is sp3d hybridization. So in this case, student, if you're talking about sp3d hybridization, So that is 1s is there, 1s, 3p plus 1d. So these are there, 5 orbitals are there, student. S, this one, this one, this one. So that is the s orbital, p orbital. No, this is px, py and pz. Here you can change it out. Okay, what change you can put it out, that is a x or y, and between them the you can put out the orbital. So this, if you see student, this, so that is, this is the sp3 dehybridization. So they will form, that is 5 new orbital, because this is 1 2 3, this is 4 and 5. So 5 new orbital will be there like that. This is the 3 orbital, and then one is top and another is bottom. So what is the shape of this, student? This with shape will be there, known as trigonal bipyramidal. This shape is trigonal bipyramidal shape. Okay, trigonal bipyramidal shape. Now student, this trigonal bipyramidal we are explaining with the help of example. So we are taking the example PCl5. So whenever you are taking student PCl5, so phosphorus is 15 and required how many electron is to unpaired electron, this is 5. So you can do the configuration 1s2 2s2 2p6, then 3s2 3p 2 to 4 6 10 12 12 3 15 3p3. So how many unpaired electron are there, student? Here no unpaired electron. Here you can see that is 1 2 3, 3 electron are there, and 3d0 is there, student. So this was ground state. Now phosphorus 15 will go, that is excited state. So if when you are sending excited state, means this electron will jump to d orbital, student. We are having d orbital like that, so it will jump to here. So see, next configuration 1s2 2s2 2p6 and 3s1 3p3 and 3d1. Now you can check out, student, here 1 unpaired electron, here that is 2 3 unpaired electron, here is what is 1 2 3 4. So here is also 1 unpaired electron. Now you can mix together, student, if you are joined together. So how many? 1s p3 and d hybridization it will go, student. Okay, now sp3d hybridization. So 5 new orbital will form, student. 5 new orbital, this is there, so this is there, this is there, right? And then one will be top and another will be bottom. You can mix it out, student, mix it out, and you can check it out, that is, this is the pyramid is there. So this is the trigonal, this is the trigonal bipyramidal, this is the trigonal bipyramidal shape. Okay, trigonal bipyramidal shape. So this is there. Here will be the chlorine atom. This is the chlorine. So chlorine, if you are putting, that is chlorine is having also p orbital, which is going to overlap. This is the p orbital. Okay, this is the p orbital, this is also p orbital. And if you are talking about the bottom line, this is also p orbital. So here is the dash line, this is the single sigma bond is there. Here also dash line, here is also dash line, student. Okay, this is also dash line. So this is the structure of PCl5, student. So this is all about the hybridization, student, that you keep in mind while in the exam. Thank you so much for watching, friends.